Hi everybody, and welcome to week 9. So for our assignment this week, we are going to continue in the third of our three-part series that we've been working on the last couple of weeks. And the idea behind our assignment this week is to add in one more concept, specifically the concept of working with outside resources, specifically over a RESTful API. Now, this is a request that was made to us by our industry advisory panel, and we've actually had quite a few requests for students to learn how to integrate different services together, because this is becoming a really common thing out in the industry, that no longer does one system live in isolation. More often than not now, we have multiple systems all needing to work together to accomplish a task. This is frequently done via RESTful APIs. So now I've had a few of you in the past in my PHP class, so those of you that have taken 3620 from me, you'll be very familiar with what a RESTful API is. Those of you that don't have experience, let's just give you a quick idea of what a RESTful API is. Now, a RESTful API is a means of accessing data on some other system, regardless of the language that it uses, the data storage technologies that it uses, any of those other things. It allows us to access objects, and we often call those nouns, to get data. That's really what a RESTful API is about, is retrieving data. It is not about performing actions. It's about retrieving data. Now, this transmission happens over HTTP. I mean, every day you use the web, you're proving that a RESTful API works, because almost every system you use anymore has some element of RESTful API or some kind of API built into it. But beyond that, even RESTful APIs are built on the back of the HTTP protocols. There's a lot of advantages to that. We don't have to do any specialized access like you did with other API protocols. Things just work, and they work really well. Because more and more, anything's expected to be able to have access to the internet. As several of you have even pointed out in the discussions over the past few weeks, even simple software like IDEs now need access to the internet all the time. So by building our API to function on those same ports and same protocols as the rest of the internet, it's substantially easier now to have that connection present and available on your end devices or in your end applications. So this week, what we want to do now is I want to continue on this idea of using courses. But rather than having the courses come directly from what your user types in, you're going to expand on this idea, and you're going to reach out to Canvas and get a list of your courses to then populate that data with. You can see the details of all that stuff in the assignment, but what we really want to focus in on is two things today. First off, I want to show you how to retrieve data in a RESTful API, and then second off is how do we parse that data. So we are actually going to use Instructure's API. In fact, this is the same API that their web interface is written in. Everything in their web interface, when you go to use their website or even if you use their mobile apps, are all done by accessing their RESTful API. So if we look at the RESTful API, this is I've got a link to this here in Canvas as well so you can see this, but this is what the API looks like. And you can see this is data returns. Here's all of the information about, possible endpoints you can call. There's a lot of data here. We don't need to get into the details of it quite yet. But first off, one of the principles of a RESTful API is data is returned either in JSON or XML. Now, XML is kind of going the way of the dinosaur. Almost everything's moving to JSON because it's substantially faster to parse and easier to work with. So when data comes back to you, for example, if you were to request a course from Canvas, you're going to get a JSON object that looks like this. This is showing you everything that's possible to come. We'll only need to use pieces of this data. We won't want necessarily everything. But if you look at the parsing of JSON, essentially is following a key value type system. For example, we have a key of ID followed by a value of 370663, or a key of any of these. Name, and the course is InstructureCon 2012. The key is locale. The value is EN. And these are nestable as well. We can store arrays. We can store other objects within these keys. JSON is a really powerful tool. Now, JSON, though, also presents a layer of vulnerability, especially if we try to roll our own way of parsing JSON. So I'm going to show you a library a little bit later on that can do the parsing for us, because if we're not very careful how we parse this data, we leave ourselves susceptible for data injection. If you've heard of SQL injections, this is substantially worse because this injects live into your application, not simply into a database. So we'll want to be careful with that. The advantage to it is JSON makes parsing this data really, really easy. So we can focus on the part that I really care about, is working out with HTTP. So we're going to use a library to accomplish that, and we'll add that in a few minutes. But if we look at this courses API, you can see there's a lot of things. For example, if I want to get a list of all of my courses, I'm going to send an HTTP GET request to the endpoint /API/v1/courses. Now you'll notice that's only the end of the URL, and that's because we need to provide the base domain. So in our case, that's going to be an HTTPS connection reaching out to weber.instructure.com. So we'd go weber.instructure.com/API/v1/courses. I'll show you what that looks like. So we can say weber.instructure.com/API/v1/courses. Ooh, that's fun. Here we go. We can see here is the data that's come back from me making this request. Now the data itself is going to be paginated. I've got roughly 300 courses in Canvas, so it's not going to return everything to me. Your list may or may be bigger, may be smaller. It depends on where you are in your education right now. But you can see an example of it, right? You can see the name comes back. We can see start ats, grading standards, public. All of those different keys that we saw in that documentation over here are returned back in that JSON document to us. So this API allows us to just reach out and ask for information back. In our case, we asked for plural, notice courses. So saying, give me all of the courses you have. Even if that means only one course, give me all of the courses. Therefore, it will return all of those course objects back to us that we can then work with. So now, what we're going to do is I'm going to pick up exactly where we were with our last sample. In fact, this is the same state it was when I uploaded it last week. We're going to just keep working with this piece now, and I want to add in the idea now of being able to reach out and download this information from our remote server over a RESTful API. Now, a couple of things have to be in place for us to do this. First, we need to come into our module app build Gradle file, and we're going to add another implementation here. We want to add the implementation that is needed for our GSON parser. Even though we're not going to do that till a little bit later on in the process, it's quite a bit easier to just do all of your little setup pieces like this at first so you don't forget stuff, and then we can come back and add other stuff later on. So what we're going to do here is we're going to do implementation of com.google. Wow, my finger's in the wrong place. Google.code.json. We're going to do a tag of JSON because we want the whole JSON library, and the current version is 2.8.5. And then go ahead and do a sync to your Gradle. Let it reach out to the internet, download all those support files, all of the code of how JSON works, so that we have it available to us later on when we're going to go. Now, the second thing we need to do, beyond just adding in support for JSON to our library, is we now need to tell Android that we need a permission to access the internet. Okay. Now, the Android permission system is, there's two different ways of approaching the Android permission system. The older style, and we still have to support it because we're backwards compatible, all of our permissions had to be defined up front in a manifest file. Now that means on older devices, it was an all or nothing. You granted all permissions or you granted nothing and you couldn't use the application. So we are going to add that still because we're backwards compatible, and newer versions of it, specific permissions are just granted inherently, such as internet connections, they're going to make the assumption now that internet connections need to be present. However, as you start getting into other capabilities, such as wanting to access location or contacts or things like that, you'll still need to set the permissions here for older style. But in the new versions, the users can choose to say yes or no to individual permissions. A lot of times app developers get lazy and they just simply keep asking the pop-up saying, oh, I need permission to this, oh, I need permission to this, until the user finally says yes or uninstalls their application. Really, that's not the way that this is intended to work. That rather, when you need permissions, you ask for them, and if the user says no, then you need to deal with it intelligently. So maybe the user says no to something crucial in your application. Well, you have to disable a huge chunk. That's okay. If the user tries to use that piece, you'll say, well, we can do that, but you have to give us this permission. So you want to use a little bit of planning around these elements as well. But for now, we're going to just go ahead and add a permission into our manifest file to tell the operating system that we need access to the internet. So to add that permission, we're going to come here in between our manifest tag and our application tag. Because this permission is going to apply to everything that's packaged together in one, not just simply the one application, because you can have multiple applications bundled together. You guys have probably even used applications or downloaded things from Google Play like that. So we're going to do a uses dash permission. Okay, uses dash permission, and we need to give it now the name of the permission that we're trying to add. So we want to add a name. As you note in parentheses there, it says it is required. To remind you, you have to have this piece in place. And the thing we want is android.permission.internet. Now this list right here is going to show you the list of all of the permissions we can add. And there's a pretty big list there. I mean, from everything from SMSs to holding weight locks to dealing with voicemail or contexts, knowing that a device has been rebooted or is started up. There's a lot of stuff in there that you can access to, but you have to have permission to be able to give those pieces. And then we're going to do android.permission.internet. Now there's nothing else we need to do in this tag. We're not going to nest anything, so going ahead and just do a self-closing XML tag will work just fine for this as well. Now, as I noted before, just one last reminder though, this is only required for older APIs. And it won't be all that long before we'll even be able to drop this off for the internet piece. Everything else would still require it here for quite a while. But pretty much, newer devices just make the assumption you need access to the internet. Older devices, though, still explicitly require the user to have been given informed consent that your device is going to be touching the internet, is an attempt to try to protect the user. So we have our permission in place, we have our Gradle file in place. Now we need to start bringing in the ability to use our API. Now we're going to need to do that via something called an asynchronous task. Now an asynchronous task in Android is a simple means of being able to do a bunch of work off of the main UI thread. Just like with Room, we don't want to have these commands and instructions on the main UI thread. What if they're on a poor network connection? We don't want the user's application to freeze while we wait for this request to potentially take 30 seconds, maybe a minute or 2 minutes or several minutes. We don't want everything to be frozen for that entire time, because we'd get what's known as an ANR, or an Android not responding error. Our application would be force closed, an error would report to Google Play, and the user would be really frustrated because they couldn't do what they want to do. So an asynchronous task is going to allow us to separate these heavy pieces of logic or time-consuming pieces into something that's a little bit more reusable than just dropping in a new thread. Now for Room, a new thread is really a great solution for that, because often the thing we're asking it to do is not something we're going to be asking over and over and over and over again, and they're not generally that incredibly long when we're interacting with the database. However, when we're dealing with something like this, we may want to be able to have, say, a progress indicator for our users, or something going on that we're making that request, and an asynchronous task is going to allow us to still maintain some connection to the main UI thread as needed, but overall it will handle most of the threading elements for us, so that we separate our logic, our business logic, from our UI components. Alright, so to make an asynchronous task, we are going to right-click on App, choose New, and choose Java Class. And then we're going to define our asynchronous task like we do with any other ones. I'm going to call ours get canvas courses. Each asynchronous task is a one job, as a one-trick pony. It's going to have one job, and if we have several jobs that need to take place, then we're going to have to write an entire asynchronous task for each of the different tasks that need to take place. It's one of the reasons why when you get out in the real world, you'll start to use libraries for some of these pieces that we're going to do by hand, but trust me, if you want to be truly effective at using those other components, you've got to be good at understanding and what's going on under the hood. If you don't understand these concepts underneath the hood, you'll never stand a chance at using something like HTTP or some of those other libraries that are really common out in the industry. So we're going to choose Get Canvas Courses. Okay, and we are going to then extend. So it is extends async task. Okay, and as you can see here, this is a templatized class that requires params, progress, and result. Or essentially, we need to define the data type. What parameters will this async task require? How will progress be returned to us? And what will our final result be? So in our case, we are going to require a string for our parameter, an integer. Okay, notice I didn't use int, I used integer because this has to be a class, it can't be a primitive. And then we will return a string at the end. So for our parameters, our string, integer, string. Okay, now it's also going to complain async task because we've got to import it. Alright, now also it's going to complain that we have some methods that we need to implement. As part of an async task, there are a couple of primary methods we need. The first one that it's complaining about now is we need something called do in background. There are a couple other methods we can use, such as onPostExecute, meaning we're finished with our background work now. We need to merge the data we got in the background with our main UI. There's a pre-execute and there's an onProgress. Each of those will allow us to implement various phases of the asynchronous task, but the most critical one by far are going to be do in background and onPostExecute. So let's go ahead and implement these. We have to, at a minimum, implement do in background, but we're going to also, while we're here, put the placeholder in. So we're going to come to generate and override. You can see all of the different ones: pre-execute, post-execute, progress update, canceled. We want to also add in an on post-execute. Okay, we're going to press OK. And now we have the basic pieces in place so that we can reach out and do the work. So in our asynchronous task, though, there are going to be a couple of other pieces we're going to need to use. So let's make a couple of variables here. We are going to make a private string, and we're going to call this, string. I'm going to call it raw JSON. So when the data comes back to us from our API, it is going to be a big string, and that's what I'm referring to as the raw JSON. We're going to need a place to store that so that we can later parse all of that together. You can also feel free to store data here if you need to make your asynchronous task work. You don't want to go overboard. Things that don't need to be persisted outside of an individual method should be declared inside of the individual method, but things that maybe need to cross over, such between do in background and onPostExecute, for example, a variable can make moving that around a little bit easier. We can also use these different return types. For example, if I return this string here in this do in background, it'll show up as the parameter here in our onPostExecute. Okay. So let's start building in the structure here of our code. So for our do in background, we need to reach out and make now a request across the internet. Okay, anything that happens in this thread will happen in a background thread, so we're separated from the main UI. So to accomplish this task, we need to set up everything necessary to reach out to the internet, make the request, receive the response, check to make sure that we got the correct response, And then we'll want to be able to do some processing with the data. Now, but because this could, there's a lot of things that could go wrong here. Maybe our URL is malformed. Maybe the server wasn't available, or maybe there was no internet connection to begin with. In those cases, we're going to want to wrap this in a try-catch, because it'll return many different error codes, or throw many different errors depending on what went wrong. So we want to try, we'll add in catches as we go, so we can explain how each of those works. The first thing we need is a URL object. Okay, this is a standard Java class, so you may have used those in the past. And we want a new URL. Okay, and our URL requires one parameter. It's a string of where are we sending this particular request to. What's our URL? So https://weber.instructure.com/API/v1/courses. Okay, same spec that we used before. Now it's going to be complaining because, again, URL, as it notes right here, throws the exception java.net.malformed URL exception. So we're going to need to add that as a catch, okay, for a malformed URL. So if the URL doesn't work, what do we want to do? Now the URL, since it's hard-coded for us, should work, but if it doesn't, that means that something will catch it build time. So I'm going to go ahead and just log it so that I could see that error take place if that's what happened. Bad URL, unable to connect. Okay, so we have a URL object, and that URL object is going to provide the ability to us to have a connection. Now specifically, because this connection needs to take place securely, we're going to do HTTPS URL connection. Let me just call it connection. And we're going to want to cast this specifically to an HTTPS URL extension or connection. By default, the URL will provide an HTTP connection, but your HTTPS is a child class of HTTP. So we can force it to go secure by some basic casting. So we're going to do URL.open connection. Again, now we're going to have another error message because this particular class, again, this method, can throw an error to us. Specifically, when I say reach out and try to make a connection with a server, what if I don't have a network connectivity? In which case, it will then throw an I/O exception because I was unable to complete the I/O as requested. So again, you would probably want to handle this more intelligently in a production application, but just for now, I'm going to just log it so that we can see that. Unable. Do you have I/O? Okay, anything that provides or causes an I/O error. In experience, most of the time when you fail in this guy right here, there's some network connectivity issue that's causing the problems. All right, so now we have a connection. We need to set a few properties on that connection before we finalize the connection. So one of the first things we're going to do to our connection is we need to set the request method. That request method, as we saw in our API, okay, that's the HTTP verb we want to use. We want to use get or post or put or update, delete. There's various keys we can use. In this case, we want to make a GET request. Now, this GET request in HTTP language is telling the server, I'm asking you to return something to me. If we were to provide a different method here, then we would be telling the server a different behavior was requested. But since we're asking for data, we are going to set our request method to GET. I'll provide that in a string argument. Now, one of the other pieces we need to have now, again, if we are in our API, is the Canvas API itself is protected. It requires a connection or a authorization from us, I guess. Now, the way that authorization takes place is through the use of tokens. JSON Web Tokens provide the ability for the user to provide their identity via an encrypted string. You know, it's, if you think about it, you have a driver's license, for example, for you. That represents and proves your identity. A JWT is going to do the same thing in a digital form between applications. So we're going to need an API key so that when this request is made, the server will know who it is that's making the request. What's the context? What user set of courses am I going to return? Am I going to return every course the server knows about? Or every course of every user? No, you don't want to do that. That'd be a big security problem. So we want to return courses that only belong to you as an individual. In fact, if you come into the API itself, you can see there's a lot of details over here. Now, typically this would happen over OAuth 2. However, OAuth 2 is way too much overhead. I mean, we'd need a couple of weeks probably actually to cover OAuth 2 thoroughly. And that's not needed at all for this application. So what I'm going to have you guys do is generate a token for you. Now, you feel free to remove this token when you submit your final application, because again, this token will allow somebody to have access as if they were you. So feel free to remove the token if you want. I'm going to replace it with my own token when I go to grade anyways. But I'll show you how to generate a token. They're pretty easy to get. So if you go to your Canvas dashboard, when your Canvas dashboard, you're going to click on your account. It should have your little icon here. Okay. Then we're going to choose Settings. And in our settings, you can see all the different connections and other things like this. But down at the bottom, you will see Approved Integrations. These are applications that have tokens that you're able to use. You can give them names, you can have dates when they expire. Like you can see, this is from when I was grading. This is a different assignment last semester that I set an expiration for it. But we're going to come down here and we are going to choose New Access Token. I'm going to give it a name, API Demo. You could call yours whatever. You can set an expiration date. If you don't put a date here, this token will live for forever. So I'm going to put an expiration date on this one that says it expires, I don't know, let's choose tomorrow. And say done. And we will generate this token. Now, a couple of really important things. If you close this box, you can never get this token back. What it says right now, here, copy this token down. Once you leave this page, you won't be able to retrieve the full token anymore, and you'd have to regenerate it to get a new version. So I'm going to take my token. That's this big string right here. It looks like gibberish to us. And I'm going to go ahead and copy that onto my clipboard. I'm going to leave this screen open just in case something happens and I need to come back to it for now. But we're going to need access to that token. Okay? So we are going to need to be able to have to set that here. Now, to make my life a little bit easier when we're grading, I'm going to make a request from you, and I want us to make a class. And let's make this class, and we're going to call it authorization. And this authorization class is only going to have a static value called auth token. So that way it's easy for me. I don't have to hunt around in your code to find where to replace the token with. I can just come straight into here to access our static token variable. So let's define that. So public static string, I'm just going to call auth underscore token equals, and let's paste in that value you just downloaded from the internet. Okay, that's all this class is going to do. This authorization class is we'll have this static string that we can then access in our code. So when I go into grade, all I'll have to do is replace this code. So when you're submitting, feel free to have it submitted like that with no string in there. I will put in a token for grading to access my courses instead of your courses, so you don't have to share tokens that represent you with me. So back in our asynchronous task we were developing here. Okay, so now the way we are going to send this authorization token to the server is again through the connection. This needs to be set as part of the header request that goes to the server. So we want to set a request property. Instead of a request method, we want to set a request property. And the property takes two arguments, a key and a value. The keys are, there are several predefined keys as part of the HTTP spec, or you can define your own as long as you prefix it with an X dash. Those are user extensible headers if your server required something like that. However, because this is such a common use case, there is a header we should use called authorization. And the authorization header is used to pass data between requestor and the server or the receiver to provide authorization to access a secured resource. So in our case, when we want to access this course's data, it's secured. Not anybody can access that course's data. So an authorization key makes that easy for us to do. Now the way an authorization key works is the way Canvas has implemented this is through a bearer token. So it needs to be the word bearer, a single space, and then we will concatenate that string in here. So then we will just simply do authorization dot auth token. So by directly using our auth token here, we can now pass that bearer token to the server. This will also make it much easier for me to grade by using a constant. Also, and when you get out in the real industry, you'll always use static constants for things like this because tokens will need to change. And they'll be dynamic, and there'll be other things like this, you know, especially with those big strings, you never ever want to embed them. That's a terrible practice. You'll always use constants for those types of pieces. We don't need to extract these strings because those strings cannot change or the system won't work. The server is looking specifically for the word authorization and the method of get and bearer. And they're not being displayed to the user, so they'll never be localized. So they're okay to have embedded strings like that rather than having to extract them out as we have in the past. So we have a URL, I have a connection that has a get request method, as well as a bearer token that's going to prove to the API of who I am. Once I have both of those pieces, now I'm ready to actually connect to the server, meaning reach out and make my request. So when I initialize my connection, I'm going to check to make sure I have the ability to connect. I can set any headers that need to take place, and then I'm going to actually go and do the actual work here. This connect is going to be the method that's going to take a long time to take place. So as our code's executing, here's where everything would stall otherwise, but we don't want it to stall. That's why we're in the async task. So we have our connection. Once it returns, it'll have a number inside of itself that will represent whether we function. Those are HTTP response codes, if you remember those from your networking class. So we need access to that number. So we want the status code because that tells us whether this worked or not. So in our connection, there is a get response code method. This will return an integer to us that tells us what happened. So in the case of a 200, that means it was an OK. A 201 would mean created. So we're gonna use in either a 200 or a 201 will basically means things worked. There's also other cases we could use here, especially if you're finding things aren't working. You can check, for example, for like a 404 would mean it wasn't found. So the server said I don't have anything there. You could do a 403 that you were forbidden, or a 401 you were unauthorized, or a 500 would means the server malfunction. There was something on the server side you couldn't fix. In general, anything in the 2s mean 2xx means success. A 4xx means it's broken. And generally, there's not a whole lot you can do about it. You know, you're either forbidden, you don't have permission to access that, or it wasn't found. You can try again, but if there was something wrong there. A 5xx means for sure there's nothing you can do at all to fix it. And a 300 means, a 3xx are used for like redirects, meaning it's moved or it's changed or other things like that. So, but in general, okay, so we're going to do a switch statement because this is the best way to handle this status. Rather than having a whole bunch of ifs and else ifs and else ifs, I want it to happen if my case is 200, or if I get a 201, I'm going to have it do the same basic thing. Put a break here to get practice. Okay, so in the case of a 200 or 201, what do I want to do? Well, that means it's success, and I have data waiting for me, so I need to read that data in and store it. Okay, so to do that, a buffered reader is going to be the easiest way to retrieve that data for us. I don't want to have to type the word buffered reader every time, so I want me to be a little lazy and type BR equals new buffered reader. Now, if you remember from your advanced Java classes, a buffered reader requires a few arguments. For example, we need an input stream reader, and it needs to know where's this input stream coming from. So from our connection, there is a get input stream. So this will allow the application now to retrieve the stream of data that came from the server, from our connection, and let's allow us to read that in a buffered manner. So then we want to just store that data, our raw JSON, and do br.read line. Okay, so give me the line of the data and let's store it in our raw JSON. Now this would be a good place maybe to do a couple of logs to make sure things are working before we get too far along the way. So we could do a couple of logs. Let's do a log.d. Okay, I've got my base log here, and so I'm going to copy and paste a couple here. So, for example, we may want to know how much JSON did we get? How much data was there? So we can do raw JSON dot length. Now you may be wondering, well, why don't you just jump the raw JSON on there? And that's because log is actually limited in length to 256 characters. That's all it can contain. So if you try to pass it anything longer than that, it will it'll clip it off. So if you need to get all of that data, then you would want to do this through a loop, I guess, and parse through all of that data at once. What I want to see though, let's look at the first 256 characters. Log JSON dot substring 0 and 256. So give me the first 256. We could also take and do the last 256, but I think if we've got the first pieces, we probably got enough. So let's just do that. We can see how long it is, and we can get the first 256 characters of it. Okay. So we have the basic pieces in here. Now, we're not parsing any of the data. We're not doing any of those elements. We're going to come back to those in a few minutes. But we need to be able to trigger this request to take place. We need to make our asynchronous task function. So what you're going to do in your application is you're going to add a menu item. Okay, I don't need to show you how to do all those pieces. These are, again, things you should have done so many times. You know how to do them now. I'll have you add a menu item that when the user clicks it, will reach out and make all of this download. Okay, I'm going to just put it in here as in our user fragment when it starts up, just because I want it to make or start happening right now. I don't want to go through all the overhead of adding it to a menu item, especially because this is a chance for you guys to show that you know some of those pieces now. So we're going to get an access to our asynchronous task. So we're going to do a private get, what did we call it? Get canvas courses. I'm going to call it task. Okay. Isn't that what we called it? Get canvas courses? It looks like for some reason when it put this in the package, it didn't add it actually to my application. It added it outside of that. So I'm going to just drag and drop that sucker in, make it refactor it, so we actually have access to it. That's really weird. I've never had it do that before. But weird crap happens, especially when you're 45 minutes into a video. So we have our task here. So what we're going to do is we're going to just simply instantiate that task equals new get canvas courses task. And then in the task itself, when we want to make things work, we don't call do in background or on post execute directly. Those are methods we should never execute. But rather, when we want to make it function, there is an execute method that is defined as part of async task. Execute requires whatever type we defined. Okay, this is where we would pass an argument for our parameters. So if we have a string that we would need to use, so for example, when you're needing to access a specific course, or maybe assignments for a specific course, somewhere where you need to send data to this, you would then pass that as whatever pieces of data needed to happen in your string. For this particular example, I'm just going to go ahead and leave that as a couple of blank quotes, because when we make the request to all of our courses, there is no argument really that we care about. So we're going to go with courses. But later on, when you need to make an individual course request, if we come back here to a course instead of courses, we don't want a list of courses. We want a not create new course. Gotta find the right place in here. Get a single course. You will pass it API v1 courses slash then whatever ID string is needed, which you'll have found from in here. So you would just pass slash 370663, for example, which is where in here, okay, you would then pass and then do like a plus strings sub 0, for example, right? That would allow me to access that first parameter that I sent, okay? But since we're not doing that for this one, that just gets you so when you need that later on, you know how to pass that data, okay? So, but again, back in our user fragment now, we can go ahead and execute our task. So let's go ahead and run this so we can see that coming in our logcat. Now when we run, as we can see that nothing's actually showing up in our log, and that's actually my fault. I put it in the wrong fragment. I'm just looking at this and realized we put this in the user fragment where we're looking at individual users, not at our main activity fragment. So we're going to actually want to come back and let's do that instead. Let's put it in here in our on resume. So we're going to take just those couple of lines we made, cut those out. So move our private variable over, and then our constructor and our execute call over to main activity fragment. And let's try this again. And there we go. Now we can see our raw JSON length is 8,672 characters, and the first 256 characters are an array of objects. We've got all that data coming in. So we know our API connection is working now. We're reaching out. We're getting our courses back. And we have our courses, so now we need to be able to process those courses. So back in our async task now, we know it's working. That data is in raw JSON. That's actually what we're going to want to return now. Instead of null, we want to return our raw JSON because we got that data. So we've got our JSON data. Now we need to process that JSON data into something we can work with. Okay. So for this example, since everything I've been dealing with so far was the user, I'm going to actually have to make a class to store this course data in. You likely already have one. However, if you do have one already, you may have to make a couple of changes. One of the key changes we have to work is when we're going to work with the GSON library here in a few minutes, it actually doesn't have access to the private variables and hasn't implemented intelligent reflection yet, the way like Room has, for example, to access your private variables via getters and setters. So we need to actually, you'll want to make your variables protected, and the key names for those variables will need to be identical between the keys in the GSON and the keys in your or in the variable names here. Now, if that means you have to make some changes, you may have to make some changes. Otherwise, you're going to have to make a different course and translate between your existing course and this course. If you choose to just refactor, that's probably the easiest way to go, but a couple of things to note. That will then require a schema change to your application. And you don't, if you're seeing errors about that and you're thinking, oh, I got to go make a method to change between schema versions and other things like that, don't worry about that stuff. Uninstall it from your emulator and reinstall it. It'll erase all of the data, but you won't need to go into the extra overhead of that kind of stuff. But since I don't have one, I'm just going to make a couple of pieces in here that we want to access. For example, a protected string. Let's have the ID. Now, in these data types, for example, if we know it's going to be an integer, we could be welcome to put an int here or a long or whatever. Protected string name. And again, these keys, the keys that I'm going to put the names for my variables, are matching the keys here. So, for example, there's one here called name. Where this guy's going to be an integer, I could just as easily change this to int if I want. But I'm just going to leave it as a string for now because it'll actually make the async task just a little bit easier for us to work with. So a string, an ID, a name. Let's do protected. Let's look here. Let's see. What do we want to do? We could do, how about course code? That could be a fun one. Let's do course code. String, course code. You get the idea. You add as many or as few as you want. The GSON library will intelligently determine which ones exist that it needs access to, which ones don't exist, and it'll ignore them. Likewise, if you have ones that you want to have access to that require other objects, then you would need to define those other pieces. Whether if it took a calendar object instead of a string, well, then you would need to define another class that said, well, this is what a calendar looks like, or an enrollment, or a term, or anything else that comes back as a nested object instead of an array. You can tell in the documentation, anything that is a nested object, they'll have some terms in here, definement in here, or in JSON it'll have more curly braces, because curly braces hold objects. For example, this permissions is going to create an object here, versus if we use square brackets, that means an array of things. But you can go through the documentation and get more pieces like that. I'm not going to make you do anything crazy. That's just for an FYI for your information. So we have a course object where we'll be able to store some basic pieces about our course as we go to start parsing this data. Again, this is going to happen in our on, post, execute now. So inside of our on, post, execute, after we've done our super stuff, we're going to want to get this data, and we're going to have an array of this information that we're going to work with from JSON. And we'll worry about getting that back into the main activity in a few minutes. But for now, let's go ahead and, again, let's try and parse this data out. So let's create an array. Oops. Actually, whoa. Let's make that variable out here. Courses. Equals JSON. We're going to make a method here. Let's call it parse JSON. So we can separate the parsing from the processing. Parse JSON, and we'll pass it result. I also like to change this name S to result because that's what it is. It makes it a little bit easier for me to remember what's going on. Okay. Oh, I called it courses. Course, not courses. That'd explain it and import it. Okay. We're going to define this method. We're going to add in a catch as well to our try. catch for just an exception. E. And log it out if we get one. Okay. Now, in this method, parse JSON, okay, again, because we can make any methods we want in this class. This is our class, right? We want to do the work here now. Because, again, I wanted to separate the work of getting this data from the JSON versus packaging it up so we can work with it in the UI. So in this method, parse JSON, we're going to need a couple of pieces here so that we can work with the GSON library. The first thing we need is a GSON builder, again following the builder pattern. So GSON builder, let's just call it GSON B, equals new GSON builder. The GSON builder's job is to build us a GSON object that we can work with, and we're going to get that from our GSON builder by asking it to create. There are arguments and other things we could provide to the JSON builder that would then reflect on the created JSON object, but we're going to be okay with all of the defaults. So we're going to want an array to hold these things to begin with. Course array. And let's set it to nothing for now, and we'll populate it here in just a minute. Again, let's wrap this in a try-catch, because now we are going to attempt to ask the JSON library to populate our courses array by saying JSON.FromJSON. Okay, and we will give it a string that contains it, and now it needs to know what is it that I'm going to create as a result. What does an individual object here look like? So we can then pass it course.class. And we can add in our what's it complaining about? Required. Oh, sorry. We need to give it the signature of an array of that. That's a typo on my part, because that's what we're asking it for, is an array of courses. So whatever it is you want it to return, this is what you're going to pass it. You want to pass it the class reference or definition of the thing that you're asking for. So let's go ahead and wrap this again now in a catch again as well. Exception E. Log it out, D dot. Okay, so this will give us our course data if we can. I'd like to add a little log here so we can see that it's working. So let's do a log.d test, and come on. And let's see if we can maybe just get the first object. Let's say first course, and then do courses sub 0. Give us that first one out there. We could find out the number of courses even. Actually, maybe let's just do that. Then we don't have to implement a toString course count, and we can just do courses dot length. There we go. That's easier than having to implement two strings. We can just make sure we're getting some courses back out of this guy. Now, the last thing we need to do here, we're getting an error message here because we're not returning anything, right? So we want to return that object that we just made. Man, my keyboard's like stalling out. So let's return our courses object. So if we parse them out, so that was a lot. Let's recap. Okay, to parse JSON, we need a JSON builder, and using that builder, we will then create a JSON object. Our JSON object, using the FromJSON method, will create whatever class definition we want from the JSON data we give it. We're logging to make sure we get it. And then if we don't, if something goes wrong along the way, we'll log that out appropriately. Then we return that back. So now, from our courses here, we're going to attempt to get an array of course data. Okay. I'm going to do a simple check if courses, because again, if it didn't work, it's going to be null. So if courses is not equal to null, then we can parse this data. So we need to, or rather we should say send to let's just send it. Let's just put send the data, okay? Because that's our job here, is we want to now ship this data out. However, now the question comes is, well, how do we, oops, we forgot to change that here too. How do we get the data out of our async task and into our fragment, where we need the data? Well, there's two different approaches you can take. One, we could have made this an inner class to main activity fragment, and if that's doable when you have a asynchronous task that will only ever be used in one place. Just go ahead and make it an inner class to that other thing, and then it would have access to all of the variables. So for example, we would have access to our adapter list, and that's something you'll see frequently. However, I chose not to do it that way in the video, even though that way is arguably a little bit simpler to follow. Simply because I want you guys to see how to get this data when it needs to be somewhere else. Okay, again, we're going to take advantage of the same concept we have been using all semester long, and we've been, dare I say, beating into your heads all semester long. A technique and concept you guys have talked about in a lot of classes, but again, as I've talked to several of you, something you've never done before. And that's specifically the idea of using an interface. So if we define an interface to this asynchronous task, we can then have our callee, or our class that has this, pass us something that implements that interface so I can send the data back out. So if we define an interface for this guy, just like we've done it with a fragment, public interface on course list complete. Sure, why not? And then let's call this what's a good name? Let's just call it course list, for lack of a better variable. And this guy now, we want to have it return the data here, because we want to have a method. Actually, let's call it this. Let's call it process course list. That makes sense. And we'll have it return the data to us. Now, we have several options here. We can have it just return an array of courses, as we've done in the past, or we could encapsulate that array of courses into something like an array list, something that's a little bit more manageable. But since the data already exists as a course array, I'm going to just go ahead and let this interface return that course array. Okay? So what we're going to want to have here is now we're going to need a variable here. Let's call this private on course complete list and callback, just like we've done in the past. Okay, we're going to need the ability now to say to on callback dot process course list and pass it. Oops, I don't want to return that. What am I doing? That's dumb. That's not the return value of this method. I'm sending the value. There we go. Okay. And it'll return void, because I don't want anything back. I want to ship it out. I had that backwards, sorry. We ship that data out. So in our process course list, okay, we want to ship out our courses data. However, in the fragment lifecycle, it was very convenient because there was an on attach. The async task doesn't have any of those things. So we want to first make sure mCallback exists. If mCallback is not equal to null, or the other way we can go about it now is the same way as we've done it in our fragments. If we don't want to do a null, we can attempt to cast it to make sure that it implements it, and then implement, because then we don't have to just make sure it's null. We could also do, because otherwise we have to say, is it null and callback instance of onCourseListenerComplete. So you have two options. You can attempt to cast it, or you can do check both of these. Either way, gets the job done. Again, in programming, there's always more than one way to skin a cat, right? The key thing, though, is if it doesn't meet both of those conditions, then we're going to throw new exception, just like we've done in the past. Let's see. Must implement on course list complete interface. Okay. That way we have our data in our asynchronous task, and now we can ship that data out. However, we need to now, right now, if we were to go run this guy, we're going to just get this exception over and over and over again. We're going to get problems with this guy because we're never setting this callback. There's no means to set it. All we have is a private variable. I can't do anything with it. So we're going to just define a public method, public void attach, or in fact, let's do this. Let's set on course list complete. Just like you've done in other classes in the past, or those other things. This is the same way, for example, that set on click listener is going to work. Is going to do the same basic idea here, is by allowing you to set the listener. So on course list complete, which will then accept one argument of on course list complete listener. And we simply need to say m callback equals listener. Okay? Because it'll enforce the data type to be the proper one here. Alright. So, we have those pieces in place. We have our m callback is being set. We can now send data to it. However, we now need to add that last piece here to our task. Before we execute it, we want to set our on-course listener, and let's just set it to this. However, right now we're going to get an error message because this fragment doesn't implement that interface. So, fragment implements on get canvas courses dot on course complete, and we can implement our methods. Okay. If we didn't want to do that, and we wanted to instead do it like you do a listener, we could have just made an anonymous inner class new on course listener, and boom, and you could do it that way. So either way you want to go, we'll get the job done. I'm simply trying to help you see the connections now between all of these different approaches we've been taking and the problem you're solving, because you're coming to the same solution the same way the Android team did. Personally, I prefer an anonymous class here. I think it's a little bit cleaner to follow than that way if I ever need to process data several different ways from a task. I like this anonymous one, so that's the way we're going to go, but I wanted you to be able to see both different approaches. So we have our task on list complete, okay, and we now have our method where we're going to retrieve a list, or we'll receive a list of courses. So first off, let's make sure we actually have courses if courses is not equal to null. Okay, if we got something back, the question to ask yourself is, well, what do we want to do with it? Now, well, with what you guys will then do is you'll have an adapter, right? My adapter is set to use users, so mine's a little bit different. But your adapter, you'll want to clear that data out. You'll want to be able to say something like course adapter, or whatever you called your adapter. What did you call it? I called mine adapter, so we'd say something like adapter dot clear. Now, notice it doesn't exist. Well, that's because we got to go make it. Inside of our adapter, we will come and let's make ourselves, oh, why didn't that go into adapter? I want to go to the definition. Here we go. Let's get to the right place here. Okay, this is our adapter. We made this method adding items. Let's make another one now. Let's call it public void clear. And then we'll just do this dot users dot clear notify, and notify the data set has changed. Again, the whole goal here is just to erase our list of items that we're maintaining internally. Okay? So we can go ahead and clear that data out, and then let's now go add that data back. So you have, again, several options. You could have a method of your adapter that accepted an array like this, or an easy way to go about it is to just make a course list. Array list, because that's what we were working with before, of type course, courses list equals new array list. And then just simply for each course, course in courses list dot add course. So we could just cycle through each of those, and then you would do adapter dot add items and pass it your course list. Now you'll notice mine's going to error out because my adapter is set to be working with users, not with courses. But you can get the big idea there of how all of this stuff is going to function. So now for you guys, you'll just need to take these concepts and apply them now to your progress in assignment number 8. So in our first assignment, we figured out how to work with a database. In our second assignment, we expanded on databases and added in recycler views. And now this third version, you're going to reach out, download data from the internet, and put that in your recycler view. And then you'll still have other things. You'll also notice in the assignment instructions there's a couple of other pieces, but they're, again, building all on these same ideas because I want to give you practice on how to implement, with working with asynchronous tasks, functioning data off of, or retrieving data and parsing data from an API, because all of those are going to be crucial skills for you when you get out in the real world. Now, as always, if you've got questions on this or you get stuck, make sure to post those on the discussion forum so we can all work together. So we'll see you guys online.